So I said like in the yesterday's class we completed the chapter, no? Today I said that today I'll be starting one new chapter, right? Yes. So today we're going to start the new chapter, that is atomic structure, or we can say the structure of an atom, right? So okay, today I'll give the introduction about the structure of the atom. Okay, and then in detail we go in the next class onwards. Same structure of the atom, what includes? Here, in this topic we are going to discuss about the structure of the atom. Means you know that any matter is made up of a tiny particles called atoms. Yes. Yes. So here, based on and it was came to that, you know, already I said, I think that the word atom is derived from the Greek language called atomos. Okay, from the Greek language atomos. Okay, so the meaning of that atom, from the meaning of that atomos is indivisible. What's the meaning of that one? Indivisible. So indivisible means what? Which cannot be broken. Which cannot be broken. Okay. So that is called indivisible. So from long back, means before like 500 BC onwards, there was a thought, okay, that atoms are the smallest particles that cannot be divided further. Atoms are the smallest particles that cannot be divided further. Okay, so that was a concept. Okay, but modern atomic theory was started when Dalton, okay, John Dalton proposed one theory called Dalton's atomic theory in the year 1805. In which year? 1805. The meaning is what? Approximately 215 years back. Okay, 215 years back. So John Dalton proposed one theory which is called as a Dalton's atomic theory. And in the Dalton's atomic theory also he proposed that he said the same thing, that atoms are indivisible. And of course some other properties also told by him. We'll discuss in detail. Okay, so here we are going to discuss in this chapter so many things. Okay, it's a very big chapter, very important chapter to understand the concept of structure of the atom. Okay, so this plays a very important role. Okay, in the main IIT mains and advanced also. It is clear to understand the chemistry. This topic is very important. Is this clear to you?
Yes, sir.
Right. So now what I'm going to explain you in this atomic structure, I'm going to explain so many things to you. Of course, now we are in the 9th class, so I think you also have this chapter like atomic structure and atoms and molecules. But it is only just a 10% of the atomic structure is there in your textbook. Only 10%. See here, only 10% is there in your textbooks. Okay. For JEE mains, when you go to the JEE mains to write an examination, here we have 100% of atomic structure. Okay, and here I am going to cover you more than 50% of the total. Okay, means compared to your textbook, I am going to cover you double and triple times. Okay, so that's what is a very important. And when you listen the concept what I am going to explain you and prepare well from this concept, then it becomes very easy to you in the IIT mains. Okay, when you enter into the 11th and 12th standard, then it becomes very easy to you and you can score very good marks. Is this clear to you?
Yes, sir.
Right. So in this atomic structure of atom, what we are going to discuss is we are going to discuss about first Dalton's atomic theory. Okay, First topic is Dalton's atomic theory. Okay. Then what we are going to discuss is after the Dalton. So this is 1805. Okay. 1805 this theory was proposed. After this, after almost 90 years, after 90 years after, J.J. Thompson, okay, J.J. Thompson proposed another atomic model. Okay, so that's called Thompson's atomic model. Okay, so atomic model he proposed. So on what basis he proposed? He conducted one experiment called the cathode ray experiment or discharge tube experiment. That also I'm going to explain. Okay, cathode ray experiment or discharge tube experiment also I'm going to explain. Okay, so he conducted one experiment, and based on that he came to know that atoms are divisible. Okay, according to Dr. Water, atoms are indivisible, but he proved that atoms are divisible. But from that, when atoms are divided, when atoms are broken, then from there some particles have come out, and he gave the name to those particles as electrons. Okay, he gave the name to that one as electrons, which are negatively charged particles. So J.J. Thompson, okay, after his cathode ray experiment, so he came to that negatively charged particles or exist in the atom. That he came to know, but he did not know about the other particles like protons and neutrons. Okay, so then okay, protons were discovered. Okay, and then here also, and also based on this experiment he proposed one atomic model, but here there are some drawbacks of that. Drawbacks means what? Like failures are there, right? And to rectify that failures, another model was proposed, that is called as a Rutherford atomic model. What it is called? Rutherford's atomic model, and he also proposed this atomic model based on one experiment. Okay, and that experiment is called gold foil experiment. What is called? Gold foil experiment or alpha ray scattering experiment, or it's called alpha ray scattering experiment. So based on this he conducted one experiment, and based on his he proposed another atomic model. Okay, and here also, of course, most of the things in this model are correct only, but still there are also some drawbacks over there. So there are also some failures over there, and to rectify that failures, okay, so another model proposed that is called Bose atomic model. That is what? Bose atomic model, and he proposed this atomic model based on the Planck's quantum theory of radiation. Based on what? Planck's quantum theory of radiation. Okay, so based on that he proposed this atomic model, and after, okay, this Bose model almost all, okay, points are correct only, but later it was slightly modified and in detailed way, okay, it was explained. So all these things, okay, we are going to discuss in this chapter. Okay, so here we are going to discuss their experiments. We are going to discuss the conclusions of the experiments. Based on the conclusions, what the models they propose, that all we are going to explain, and then we are going to discuss about the failures and how their failures are rectified in the next coming models. Okay, so all these things we are going to discuss in this chapter, in this topic. Is this clear to you? Yes, yes. Last one, Bose atomic model was correct. Okay, so last one is correct. But see here, when you can have a doubt, like, okay, thought that if the last one is correct, then why we are going to discuss all these things. Okay, so you should know that, okay, failures are the successive steps. Yes or no? So what do you say that failures, there is one pro or no? Okay, failures are the steps for the success. Okay, so if we study from starting onwards, then we come to know that what are the failures and how are they rectified. Okay, so these things we learn so that you can understand very perfectly, okay, everything. So that's what anywhere you can see, we don't directly read what is a completely, generally you don't, okay, if you eat directly which is cooked food is there, directly if we eat 1 minute, just a minute. So now we easily come to know that we know, okay, actually now you people know that, now we are in 8th class, 9th class only you came to know that any matter is made up of atoms, and atoms are divisible actually, okay, you know that, and atom consists of more tiniest particles like electrons, protons and neutrons, and what are the charges, where they exist, and everything you know, okay. But to explain all these things, approximately more than 100 years, okay, there was a hard work of more than 100 years of different scientists were there, okay, to know this one, okay. So for example, see, whatever we are enjoying, it looks like a, okay, it's very easy, okay. So for example, if you take simple one, if you take a mobile, if you take a mobile, then you can say that you know everything about mobile, okay, you know, okay, this is a mobile. But see, to, okay, invent the mobile, how many years the scientists might have worked out, okay, and how many step by step how it was there, yes or no. For example, you see, the first time, okay, first time I have purchased mobile, that in the year 2000, exactly 2000, okay. At that time, 2000, the first mobile I have purchased, that's like one box, okay, one box, and like okay, keypad like 1 2 3 4, and inside also just a small screen with the black and white, okay. And of course there was a facility for messages, that's all, no other facilities were there, okay. And then when it came to like 2005, 2006, 2004 or 2005, and then we got new model which is color screen, but model was same, like a small phone, okay, that keypad and something like this. And then we came to know that 2006, 2007, 2008, I think I purchased one BlackBerry phone, which is a QWERTY pad mobile. Means like now whatever the latest they QWERTY, so that, but screen was small. And then I think in the 2010 something, it was arrived like what, Android phone, okay. And now we are enjoying everything, YouTube in that, everything. Now actually the mobiles are not like a computer now, okay, more than computer, more than system, okay. If you have one laptop, and now these mobiles are like more than laptop, yes or no. So laptop you have to, it's a very big, and it's almost 1.5 kg, okay, to carry anyway, and you need to open, and you, this all that. But here you can see, you can very easily you can carry, okay. So everything we can do, whatever we can do in the system, and we can, now we can do in the mobile also. But only thing that is a small. Is this clear to you? So here first, so there are how many years? See, you know, I think the actually first phone was invented with the Alexander Graham Bell. You know this one? Who invented the phone? Telephone? Alexander Graham Bell. When? In 18th century. In 18th century. At that time, 18th century. Now this is what? 2000. Okay. So in this many years took like now at what stage we are in this mobile? Okay, stage. So like this, okay, then the upgradation will be there. So if we know all these things, then only you can think that what should be done in the next one. Yes or no? So that's what, to understand anything very perfectly, you have to go through the roots of that one. Go through the roots of that one, so that you come to know everything very, very perfectly. You can understand, and what are the problems in that, you'll come to know, and you'll also come to that how to rectify. If the problems comes, then we can rectify. Yes or no? So if everything is ready-made arranged to you, okay, for example, say every day your mom is cooking and everything is ready-made is given to you, but suddenly you think one day you have to go some outside and you got struck, okay, and you don't know the cooking, then how can you, okay, and there is no hotels and there is no money with you, but think, okay, you have that utensils and everything to cook, but you don't know, then how, okay, so you should know everything. Is this clear to you? Okay, right, so that is the thing, right. So now we start with the structure of the atom. So this is in this chapter we are going to discuss, okay, Dalton's atomic theory, J. Thompson's atomic model. So in this experiments also there, that experiment also we are going to discuss, which is not there in your textbook, and Rutherford, then Bohr, and everything we are going to discuss in this one. So first we discuss with the Dalton's atomic theory. Akanksha, or CPSC or SSC? SSC, huh? Do you have this chapter, atoms and molecules or structure of the atom in the 9th class? Yeah. Is it completed? Acha. Okay, no problem. Now we'll discuss one by one. So here, as I said you, even in India or even in Greek, okay, countries also, the people at that time, what we can say, okay, so like what I can call them as okay, so not scientists, but they are philosophers. We can say the philosophers. Okay, so those philosophers had an idea that any matter is made up of a tiny particle. Okay, like if I have this object, so I can break it. So if I apply the force, so it can be broken into two pieces. Again I take one piece, again I break. So like this continuously I'll break them. Then finally what happens is there a stage will come where we cannot break them. So such unbreakable particle is called an atom. So there was a, okay, so this concept that people, okay, the philosophers, okay, of Greek, even in India also before 200 or before 500, okay, BC, okay, they had an idea. Okay, now the same concept taken forward, okay, by the Dalton's atomic theory. So Dalton, his full name is John Dalton, okay, in the year 1805. So in year 1805, his full name is what? John Dalton. Okay, John Dalton proposed one atomic theory. Okay, so not only on that one, but he also proposed these laws based on that laws of combination. I think you might have studied about the laws of combination. Okay, so there are some laws of combinations all there. Okay, laws of combination. So these combinations also he, okay, took into consideration. In these two laws of combination, one is what? Law of conservation of mass. Law of conservation, okay, of mass. And the second one was okay, law of constant. Okay, law of constant or definite, anything you can write. I am writing here constant. Law of constant proportions. Okay, so these laws, these two laws are called as laws of combination. So in this laws of, based on this laws of combination, actually what this law states that, this first law states that mass can neither be created nor destroyed during the chemical reaction. Okay, so whatever the mass of the reactants will be there, the same mass, okay, will be of the products also. And second law, what it states that, okay, any matter, like any compound, any substance, okay, the composition ratio remains constant. Like if you take the water, in the water formula is H2O, okay, H2O. In this 2 hydrogens and 1 oxygen. So your ratio of atomic wise is 2:1, but mass wise is 2:16, because 2 hydrogens are there 1 and oxygen of mass is 16. So that is 1:8. So this is fixed. Whatever the source may be, whatever the method you prepare, okay, here to form a water, hydrogen and oxygen are combined in a fixed ratio of atoms of or mass, anything. So this is called as a law of constant proportion. Okay, so these are called as laws of combination, and from these laws of combination and old theory, okay, by taking all this into consideration, so Dalton proposed his atomic theory. So what is this atomic theory? Okay, Dalton's theory states is Dalton's atomic theory Okay, so states this. Now see the first point. Okay, any matter is made up of a tiny particles. Any matter is made up of, okay, a tiny particles called atoms. So this is old point only. Okay, the new concept is not there. The first point is what? That matter is made up of a tiny particles called atom. This is old concept. Now second one, what is said that, okay, these atoms are indivisible and invisible. Okay, so indivisible will write down, invisible not required. Okay, so concept is that atoms, these atoms are indivisible. This what? We cannot break them. Okay, we cannot break them. Okay, and third one, what is said is, okay, so third one, what is said is atoms of same elements, atoms of same element, okay, have similar properties. Similar properties. Okay, the meaning is what? For example, if you take any material like copper, you take. Okay, you take a piece of copper. From that you take, okay, this copper, for example, a piece of copper. But that piece of copper contains how many atoms? Some millions and trillions of atoms over there. Okay. Now from that anywhere you take 2 or 3 copper atoms, and if you check the properties, okay, if you check the properties, then you'll observe that all copper atoms will have the similar type of properties. Yes or no? Because all are copper, so they have the same properties. Now, for example, take the copper from here, okay, from one shop in Hyderabad, and you can take copper from Vijayawada, or you take copper from, okay, pure copper from Vizag, something different places you can take, and then you take that, okay, different places copper atoms, and if you check the properties, here also the properties remain same because all are copper only. Yes or no? So from this, what we come to know, atoms of same elements, atoms of same element have similar properties. Similar properties. Okay. So that is about the third one. Now fourth one, what is said? Atoms of different element. Okay. Atoms of different element have different properties. Okay, so the meaning is what? Here, for example, you take one copper atom and you can take one gold atom. Both are metals only. Both are good conductors. Both are solids. Okay, but you take one copper atom and take the gold atom. And if you see the properties, whether all these properties remain same for all both this copper and gold? No. Okay, even though both are metals, even though both are solids, okay, but still their chemical properties are different. Their properties are different. So because they are not same, okay, they are of different compounds, different elements. Okay, so the atoms of different elements have different properties. Now fifth point, what he said is, okay, atoms will combine. Atoms, okay, combine in small mole ratios, okay, in small mole fixed ratios, okay, fixed ratios to form compounds, okay, to form compounds, okay. Just want to like if you want water, okay, so in that water fixed 2 hydrogens, 1 oxygen, okay, all small mole, okay, fixed ratio. Carbon dioxide, 1 carbon, 2 oxygen, that is fixed. Anywhere you can take the carbon dioxide, the ratio is 1 carbon, 2 oxygens. You take water from anywhere, that 2 hydrogens, 1 oxygen, okay. You take ammonia, anywhere, so in that also nitrogen 1 and 3 hydrogens, the ratio of hydrogen, the ratio of 1:3. So the fixed ratio, okay, fixed ratio, the atoms will combine to form a compound. And last and final point, just I told that atoms can neither be created nor destroyed during the chemical reactions. Okay, so the sixth point is what? Okay, the sixth point is what? Atoms can neither be created nor destroyed during chemical reactions. So these are the this is the concept of Dalton's atomic theory. Okay, this is known as Dalton's atomic theory. Okay, so once you see here, once again I'll explain all this, and you have to note of this all the points, and you have to learn here itself at least one point, read three times. Okay, so that it will be easy for you. So once again say here, John Dalton in the year 1805. Remember that. Okay, in 1805. John Dalton actually was a school teacher, was not a scientist actually. So was a school teacher, but still he proposed the atomic theory. Okay, based on what concept he proposed his theory? Based on the old concepts, and also he took the law of conservation of mass and law of constant proportions into consideration. He proposed his atomic theory, and the points are what? Matter is made up of a tiny particles called atoms. That's the first point. Second point is what? Atoms are indivisible. This is what we cannot break the atom. Third point is what? Atoms of same element have the similar properties, and this same element have the same properties. And the fourth point is what? Atoms of different elements have different properties. And fifth point is what? Atoms combine in small whole fixed ratio to form the compounds. And last and final point is what? Atoms can neither be created nor destroyed during chemical reactions. Is this clear to you? Chalo. Now read each point three times and you write in your notes. Okay? Completed? The sixth point also? Yes. So, this was the Dalton's atomic theory. Right? Now what happens? Okay. So, this theory was proposed in the year 1805. Okay. But later what happened? So many scientists they tried to conduct experiments, to see the effect of electricity on the various compounds. Okay, like the electricity. Okay, electricity. So they would like to see what is the effect of electric current on the various substances, even like solids, liquids, and gases. Okay. Now after that, then what happens? Here Michael Faraday. Okay, Michael Faraday was the one scientist. Here I am not going to discuss about it very detailedly because actually this is not concerned to this is not completely concerned to our topic. So that's what just I'll brief about him. So Michael Faraday was a person who conducted some experiments to see the effect of electric current on the solutions Okay, so then what he has done, he conducted some experiments on the solutions. Okay, and that conducting the electricity by passing through the solutions effect, and those experiments are called electrolysis. What they are called as? You know, I think in the lower classes you might have studied somewhere about the electrolysis. Okay, so what is meant the electrolysis? Electrolysis. Do you know what's meant the electrolysis? Okay, the process of decomposition. Decomposition is what? Breaking or splitting. The process of decomposition of a chemical compound into its constituent ions. Into its constituent ions by passing electricity. By passing electricity is called electrolysis. Okay, so I think you might have studied about the electrolysis of water. Yes or no? Okay, so electrolysis I will explain by taking electrolysis of water as an example. Okay, if you take one beaker, this is a beaker. Okay, and that you take some water. Okay, so this is the water. In this water, actually pure water is a bad conductor. Do you know that pure water is a bad conductor? Okay, so that's what is that the small amount of salt or acid or base should be added. So you can add some acid. Okay, small amount of acid is added. So why? To make it as a good conductor. Okay, then what we do? We insert two electrodes in it. Okay, we insert two electrodes. Electrodes means you know what is the electrodes? Electrodes means what? Metallic plates. What are they? Metallic plates. Okay, so like this, insert two electrodes. Okay, and these electric plates, sorry, these metal plates are called electrodes, and these metal plates are connected, okay, through the copper wires, okay, and one key, and this is one battery. You think this is battery, okay? Like this, if we connect them, and then if you pass the electricity through it, okay, if you pass the electricity through it, then what happens? Okay, so here you see this is the positive terminal, this is a negative terminal. Yes or no? And the electrode which is connected to the positive terminal, okay, is called as an anode. What it is called? Anode. And the electrode which is connected to the negative terminal is called as a cathode. What it is called? Cathode. So this is called anode, that's called the cathode. Now when you pass the electricity to the water, here I am taking a water example. Okay, but Faraday have taken the different solutions, but I am explaining you by taking water as an example because this you can understand very easily, and in the lower class also you might have studied about the electrolysis of water, right? So now when you pass the electricity, then what happened? This water, that is H2O. Okay, it splits. Splits means what? It decomposes. Decomposes means what? It breaks. Okay, it breaks into two types of ions like H plus and OH minus. Okay, it breaks into water. It splits into what? Okay, two types of ions which are called H plus and OH minus ions. See, H2 hydrogens H2O, H2O, 1 plus 1 minus becomes neutral. So this is the this is called electrolysis. Okay, this is called electrolysis. Electrolysis means what? The process of decomposition. Decomposition means what? Breaking. The process of decomposition of a chemical compound into its constituent ions by passing electricity. So this is called. Now, when they pass like this electricity, then they came to know that here two types of charged particles are released. Okay, so one is called positive and the second is called negative. Okay, right? And these positively charged particles are called cations. What they are called as cation. What they are called? Cations. And this negatively charged particles are called anions. What they are called? Anions. Okay. So based positive is anode. Okay. And negative electrode is called cathode. But ions, when you come, positive are called cations, negative are called anions. Why? Because you know that like charges repel and unlike charges attracts. Do you know this one? So here whatever the positively charged particles will there, these are attracted towards the negative charge because opposite charge is attraction. No?
Yes, sir.
So positively charged particles are attracting towards where? They are attracting towards the cathode. They are attracting towards the cathode. So that's why they are called as the cations. Is this clear to you?
Yes, sir.
And here second one are what? OH minus. They are negatively charged ions. Yes or no? They are attracted towards what? Positive charge because opposite charge is attraction. No?
Yes, sir.
So positively charged particles attracted towards the cathode. Negatively charged particles attracted towards the anode. So here positive charged particles attracting towards the cathode. So that's why they are called as cations. Okay. And negatively charged particles attracted towards the anode. So that's why they are called as anions. Which are attracting towards the cathode are called cations. Which are attracted towards the anode are called as anions. Is this clear to you?
Yes, sir.
So yeah. So now this was an experiment, and of course after this experiment, based on this type of experiments, Faraday proposed two laws. Okay. So Michael Faraday, his full name is. So Faraday proposed two laws. Those laws are called Faraday's laws. Okay, of electrolysis. Okay, so there are two laws of the Faraday's laws of electrolysis. Now we are not going to discuss about this Faraday's laws of electrolysis. Of course, this is a part of the chemistry, but we discuss in one more topic called electrochemistry. Okay, so there is one more topic with there, and that chapter name is electrochemistry. Then we are going to discuss about this Faraday's laws. Now we are not concerned with that. Okay, but here why we are taking his name and this experiment was here. So here by passing electricity, here this is positive charge and negatively charged particles are released here. Yes or no? Positive charge and negative charges. Now the question arises that, okay, from where these charges has come? Okay, so here we have a Dalton's atomic theory. According to Dalton's atomic theory, okay, already studied what are the properties of atomic theory. So we studied these all the properties. Okay, but it never have come anywhere about the charges. Anywhere is there charges? What is there? No. Okay, in the atomic theory, anywhere you can see about the word called charge? No. So now the question arises that from where these charges have come? Okay, so atoms are neutral, atoms of the individual particles, atoms cannot be divided further. Okay, but then how these charges are produced? From where these charges have come? This was a big question. Okay, so to explain, okay, from where these charges have come to these atoms, okay, of course later J.J. Thompson explained from where these charges have come. Okay. So that J.J. Thompson model was the second one. The next topic after the Dalton's model, that in the next class I am going to discuss with you because it's a very big. So it will take one class. So in the next class I am going to explain J.J. Thompson's experiment and then his atomic model. Okay. So as of now till what I explained that you understood everything. So listen carefully. So once again, okay, tell you that it's a very important chapter, and see total chemistry is depend on this chapter. Okay, so chemistry has started from here. If you know and if you understand this one, what are atoms, what are electrons? Okay, so these are all what is atomic structure. Then the chemistry becomes very easy. Okay, so this chapter plays a very important role if you to achieve the IIT mains. Okay, so that's what concentrate, and what you are writing or what you are taking the screenshot. If you are taking the screenshot, that you clean neatly write in notebook, maintain and read it. Okay, on regular basis. Okay. Yeah. Okay then. So I think we have one more class. So at 6:40. Okay then. Bye for today.